Hi everyone. Today we're going to look at a problem that uses either the law of sines or the law of cosines to solve an application problem. So let's see what we got here. So the problem we are given is the following. Juan and Romelia are standing at the seashore 10 miles apart. The coastline is a straight line between them. Both can see the same ship in the water. The angle between the coastline and the line between the ship and Juan is 35 degrees. The angle between the coastline and the line between Romelia is 45 degrees. How far is the ship from Juan? Okay, so it's important that we draw an accurate diagram when we are doing these types of problems. So, we have a very straight shoreline here. And we're going to put Juan here. And he sees a ship in the water at a 35 degree angle. So we're going to put a ship in the water, and we have 35 degrees. Okay, Romelia sees the ship at a 45 degree angle. And we know the distance between them is 10 miles apart. Alright, here's Romelia. Alright, so we want the distance from the ship to Juan. So, we will label that X. Well, let's see what we know. We have this triangle here, and we're going to need to find this angle here. Well, these two angles are supplementary, so you're going to do 180 minus 45, so that's going to give me 135 degrees. Therefore, this angle is, you're going to add 135 plus 35, and you're going to get 170 degrees. And all the angles of a triangle add up to 180. So therefore, that angle would be 10 degrees. Okay, so now we have an angle and the side opposite that angle. Okay, and as we have previously learned, now we would want to use the law of sines to then compute what x would be. So we simply state the sine of 10 degrees over 10 is equal to the sine of 135 degrees over x. Then we carefully cross multiply. Sine 135 equals x times sine of 10 degrees. So we're going to divide by the sine of 10 degrees. And this would then tell us the value of x. So we're going to carefully type that into our calculator. And before you proceed, you want to make sure that you are in degree mode, which I am not. So that would cause an error in our calculations. Okay, 10 times the sine of 135 divided by the sine of 10. Okay, therefore, x is approximately 40.7. And since our units are miles, okay, we know that Juan is 40.7 miles away. Now, you may think you're done with the problem, and I bet that's the textbook answer for the problem, but who's to say that Romella is actually on the same side of the ship as Juan? Okay, she could be way over here. And would that change the problem? Would that change the answer? Well, we're going to draw another diagram and find out. So, we have the straight seashore, okay, and we have Juan here, and he is still at a 35-degree angle to the ship. Okay, this time we're going to put Romella over here at a 45-degree angle. Alright, so once again, they're 10 miles apart. Alright, so we're going to, and this is 35 degrees here. Alright, so now we're going to calculate the problem with this information and see if we get a different answer, which I bet we do. Alright, so we have two angles of the triangle, so we can get the third angle by adding these two and subtracting from 180. So that looks like that's 80 degrees, so you're going to do 100 minus 80. So therefore, the angle here would be 100 degrees. And once again, we can set up a law of sines equation because we have the angle and the side opposite. So we have the sine of 100 degrees over 10 is equal to, and we're looking for the distance from the ship to 1, so we're going to call that x. So the angle opposite the x is 45 degrees. So we're going to do sine of 45 degrees over x. So once again, we're going to cross multiply. X sine of 100 is equal to 10 sine of 45. Okay, solving for x, we want to divide by the sine of 100. So we would get x is equal to this quantity, which we're going to enter into our calculator. 10 sine 45 divided by sine of 100. And in this case, Juan would only be approximately 7.1, or rounding to one decimal place, about 7.2 miles from the ship. So, the information in the problem, you have to be very careful about these problems because sometimes it's ambiguous and you really, have to consider all the possibilities, okay? So our first possibility is if they were on the same side of the ship, Juan would be 40.7 miles away. Or the second possibility is if the ship were between them, Juan would only be 7.2 miles away. Well, I hope you enjoyed that.